Good morning, grade 11s. So we are going to do some examples here to find the angle of inclination between two lines. So in this first example here, we've got to find the size of alpha, which is sitting between two straight lines. So now we know that the angle of inclination is always from the horizontal going around. We need to draw ourselves a horizontal line there. And if we need to find alpha, which is sitting between those two lines, because we have the equation of that straight line and the equation of that straight line, we remember our formula, tan of theta equals m, which is the gradient. Because I have the equation of that line, I can find the gradient of that line and therefore also that angle of inclination. And because I have the equation of that line, I have the gradient, I can work out the angle of inclination of that line. So now, if I want to get to little theta, which is sitting, it's alpha, sitting there, I just need to take the bigger one minus the smaller one. And that will be giving me my answer. So let's have a look at the solution here. If we go back to the top here, I forgot to mention that the gradient of this line is going to be the 1. And the gradient of this line here is going to be minus 2, which is correct because it's got a negative gradient and the angle is bigger than 180 degrees. So if we go back to our solution over here, we're first going to find this little angle here, theta 1, which is going to be this line here. So on the calculator, we go shift tan 1 and we get 45 degrees. And then our second one that we're going to work with is this line here, which is the bigger one. So that's tan of theta 2 equals minus 2. And because it's an angle bigger than 180, we would go 180 degrees minus shift tan 2, and we get 116 degrees. But because we're wanting this angle nestled between the two, we're going to end up going the bigger angle, which is 116, minus the smaller angle, 45, and we end up with the answer of 71.57 degrees. So it's finding two angles, subtracting them, and then we get to the one that we want. So now we move on to example 2, where we need to find the angle theta, which is sitting over there. So now what we need to do is we need to think of a strategy before we dive in and we use this formula, tan of the angle of inclination equals m. Before we look at that, we need to think of a strategy. How am I going to find alpha, which is sitting between the two lines AB and CD? And we know the first thing we always need to do is we need to draw our horizontal line. And at the moment, alpha is a little bit above the horizontal and below. So we've got to think about how we're going to go about this. Because we've got line CD, we can work out that angle there. And because we have line AB, we can work out that angle there. And that's going to be very useful because if we subtract the two, the bigger one minus the smaller one, I'll be able to work out that angle there. And if we look now, we've got our straight line. And if I go straight line minus that angle, BPD, I would have found alpha. So that's the strategy. So let's go through it again. I'm going to try and use a different color here. So we're going to first find out this angle here. Then we're going to find out the bigger angle of inclination and subtract the two, which will enable us to then go and find out this angle here, which if we use angles on a straight line, we've then got alpha. So that's going to be our strategy in this case. So now that we've got our strategy, we can go look more specifically at our little formula. But to use the formula, we need gradient. And in this particular example here, the gradient is not given. So our first step is going to be to work out the gradient of line AB and the gradient of line CD. So if we work out the gradient of line AB, we're going to get -1/2. And therefore we can work out the angle of inclination, which is going to be shift tan 1/2. And because it's bigger than 90, it's going to be 180 degrees minus the acute angle, and we get 153.43 degrees. Then we move on to line CD, and we have D 2, C 3 minus 2. So my gradient there works out to be -4. And the angle will be shift tan 4, and we end up getting 104.04 degrees. But now, if I take the bigger one minus a smaller one, I'm going to be able to work out the angle there, that little BPD, which is going to be that angle there. So that angle BPD is going to be 49.39 degrees. But that isn't what I'm looking for. What I'm looking for is this angle here. If we look at the original question, is that angle there, which is alpha. So to find that angle, my final answer is going to be 180 degrees minus BPD, which I worked out, which ends up being 130.61 degrees. So my angle alpha, the one that I was looking for, the original question, is going to be 130.61 degrees. Now we move on to example 3, where we need to find alpha, which is situated over there. So remember, our starting point is to draw ourselves a horizontal line, because angle of inclination is always from the horizontal going clockwise. And we've also got our formula, which is very useful in order to find alpha. Now, for a strategy here, we think, okay, how am I going to find alpha? And this one isn't too bad, because if you look at alpha, which is there, it's made up of a 90-degree angle, and it's made up of a little acute angle there, which is just the angle of inclination of this line here. So once you break it down, it's not bad at all, because it's 90 degrees plus the angle of inclination. That'll give you alpha. The only thing here is, because we want to find the gradient, this line which is given is not in standard form. So now let's go and have a look at the solution. So the first thing we would need to do here is to get this line into standard form so that we can find the gradient. So we take the 3x across, we divide by 2, and we pick up that the gradient is in fact 3/2. So to find the angle, we're going to use our little formula, and then we're going to go shift tan 3/2 on the calculator, and we get 56.31 degrees. And that is your angle of inclination, which is going to be over there. But the complete angle that we're looking for is that one there, which is going to be 90 degrees plus the angle of inclination. So my final answer is going to be 146.31 degrees. There we go.